had a question dealing with some Chapter 29 material, and the question was asking about these two equations here and how they seem to be in error with each other. So the first one is the voltage difference of a battery, which we call a little squirrely E, the EMF, and this is the chemical work divided by the charge. And then we have this other equation that says the negative work divided by charge equals the change in the potential. Now what they're leaving out there is that this negative work is the work by the electric field. So this is actually the question dealt with question 29.8 from the text, 29.8 exercise. And if we model our battery kind of like a little capacitor, just to be able to talk about it a little bit better, okay, what's happening here is they're moving an electron from this end over to here. And they say that the work done is, I think, 2.4 times 10 to the negative 19. You should probably check me on that to make sure that's right. Now, the thing about this is that if you look at the forces on this charge, there's some force of the chemical pushing that way, and then there's the force of the electric field that way, right? We know the electric field from this positive to this end is going to be this way. And so we can call this maybe the positive potential, and this is the negative potential. So the electric field is going to be doing negative work. And the thing is, so if we write this out, chemical is going to be doing positive, and then the electric field is going to be doing negative. And the thing is, they have to be equal. Why is that? Well, because the electron starts and stops at zero velocity. So there's no total work done. And so whatever these two are, they have to be equal and opposite of each other. So this is positive, that 2.4 times 10 to the negative 19 joules. And this is negative, that 2.4 times 10 to the negative 19 joules. And so we write out our equations. You can actually use either one. So if I do the change in the voltage of the battery, since my final position is the voltage negative, it'd be Vn minus Vp. And then here, so this is chemical divided by the charge. Well, the chemical is positive 2.4 times 10 to the negative 19 joules divided by the charge of an electron, which is negative 1.6 times 10 to the negative 19 joules. And so I get negative 1.5 volts. Now I can write this way here by just sliding over that Vp. And this says whatever Vp is, Vn has to be 1.5 below that. If I use this equation, which you're totally welcome to do, you gotta remember that that's the work done by the electric field. And so this will be negative of negative 2.4 times 10 to the negative 19 joules divided by the negative 1.6 times 10 to the negative 19 joules. And if I do that, these two negatives cancel, and I get the exact same number. And I get, in fact, I can write out this equation here, since my delta V is also Vn minus Vp. And then basically the thing is that generally with EMF, we just do the absolute value of it. And so it's 1.5 volts.